So my name is Meytal, and soon I'm going to tell you what I'm doing for a living. Today I'm going to present you with a project that I did like a while ago when I actually tried to learn Python. So in my profession, I used to use R for all my analysis, and then I realized that I need to move to Python because all the rest of the world is doing Python. So I went to She Codes and to study Python, to learn Python, and then eventually I needed to end up with a final project. And I wanted to have a project that is relevant for my everyday life and will ease my work, because whenever you do something repetitively, you want to automate it. So I decided to do something that will help me. So I ended up with Seenopsis, and I'm soon going to show you what Seenopsis is. So I confess, I'm an epidemiologist. Is there a person in here that know what epidemiologist is? Wow, this is so many people. Usually there's only one. So for those of you who doesn't know, usually people are saying that, thinking that epidemiologist is someone that is a specialist on skin disease. No, don't show me your moles. And the other people who don't know what epidemiologist is think that it's all about epidemic, but it's true. Some of it is related to epidemic, but it's all not about the outbreaks, like the measles outbreak. I know nothing about it, so don't ask me about it. Just vaccinate your kids. So epidemiologist is actually a person who deals with the methodological aspect of medical research. So for a living, what I do, I design the studies and I think about the best analytic solution to answer the study question. And a lot of the methods that Amir was mentioned before, like he mentioned the, for us, we're telling repeated measurements. We do it with Bonferroni. He changed the p-value, remember? So we use Bonferroni, we use FDR, we use all this stuff just to, I guess, to get into the same solution. And he showed you the diff and diff. This is something that we use for causal inference. So we do this a lot. So I'm the data scientist of medical research, because we use exactly the same methods, very similar method at least. So my specialties as epidemiologist is dealing with observational studies of electronic medical records. I'm not sure if you know, I'm sure you do. I'm not sure, but I am sure that every encounter that you have with the health system here in Israel for the last 25 years is recorded in the computer. So if you call to the Moked, it is recorded. If you do a blood test, it is recorded. The results are recorded. If you have a prescription, it's recorded. And if you go to the pharmacy and purchase the medication, it's all recorded. And it all gathers into one big database. For specifically me, I'm working at the Clalit Research Institute, and we're gathering all this data. And eventually we take all this data and we ask some question on the data and answer with what we have at the data. So in the life cycle of a study that I do, first step is to gather all the information from everywhere, from all the fields at the right date, at the right code, and then to have a big flat file. And once we have a big flat file, I really want to feel the data. I want to play with the data. I want to make sure that I have a complete data. I want to see if my data is messy, it's not messy. Is there outliers? Is it complete? I want to see the data. And this is why Seenopsis is all about, seeing the data. It's a visualized snapshot of variables in a database. So the Seenopsis is a first exploration of the variables in the database. And it centralizes the main important features of the features. We call it variables, but it's the features of the features. And it do it in a structure visualized approach. The how. So I did this project to study Python. So I wrote it in Python and I used the regular libraries, the pandas, the NumPy, the matplotlib. And all you need to run Seenopsis is Python and dataset. So I can talk a lot about Seenopsis, but I think that a live demo would be better to show you what Seenopsis is. You know how always they told you that in demonstrations, you don't supposed to have a live demo, but I'm so sure of this, so I'm presented the live demo. So all you need is to write import Seenopsis and then Seenopsis process CSV, and then it's open a file. And then you have to choose your database. In this case, I choose my database as a CSV file. I've prepared ahead of time. I've prepared a fictionary database that is based on distributions, real distributions that we have in the Mechon from the Clalit database. These are not the real data because we're not allowed to show nothing from the Clalit, but it's all based on real distribution that we have. So generally you have, so you see this is the synopsis of, you have 15 variables in this database, you have 50,000 observations, and this is the synopsis of the database. This is the visual way of the database. So in here you see all the variables in the data and what type of variable, the graphic representation, the basic statistic, missing and outliers. So the thing is that when I explore every data file, I do this repeatedly for every single variable to fill the data. So Seenopsis put it all in the same table. So let's go over it and understand what we have in here. So the index date, you see, it means nothing, just means a date for where you start to follow up a person. And then what is important for me is to see that there is no missing data at the index date, because I need everyone to have a starting point. So the index date is less relevant in here, but what you can see, you see the first line is static and then you can move forward. So the next variable that I have in the database is source of data. Source of data, it's a single variable, meaning that there is no variance in this variable. Every single observation of the data set has the same value for this variable. So it doesn't help me. I can just delete this variable. I have nothing to do with this variable. But this thing I get in a snapshot with Seenopsis. Okay, var1 weeks, it's a variable that is counting in weeks, okay? So I say that it's a continuous variable, and then I see the distribution, it's a histogram. But if I'm looking on the basic statistic, I can see that it starts from -1, which doesn't make sense. Okay, so there is a problem with my data. I saw it in a snapshot, and now I need to go back to my data, understand what is this -1, because it shouldn't be minus. There's supposed to be only positive values in here, but something is missing in here. I see it's normally distributed with long left tail. So I need to think, what do I do with these outliers? You see, there's 388 outliers. I made the outlier based on the 3 IQR from the 3 interquartile range from the median, the distance. And another thing is that this variable is available for only 50% of the population. So now I need to think, what do I do with this? It gives me the opportunity to think ahead of time, like before I even model something, what do I have in here? How do I approach this variable? And it gives me the opportunity to think ahead of time. Do I want to do multiple imputation in 50%? Not recommended for our data, at least. I need to think what to do in here. Another variable, I can see that it's not distributed normally. It has a long right tail. Now I want to know if my data is correct about this variable, because I know from past experience that, for example, BMI, LDL, they're all distribute the same as this distribution. If they're not normally distributed, does this fit to to my prior knowledge? So in here, I can know if my variable is okay. This is a classic representation of a digit preference. Do you know what a digit preference is? Okay, so you see in here, it's kind of normally distributed, right? But look, not all the values have the same chances of representation. For example, do you remember that back in the old days, when the nurse measured your blood pressure, she used to do it with a pump, with a manual pump, and then if it was 103, she didn't write 103 because she couldn't be that specific, right? So she wrote 105 or 110. 103 did not get the same representation as 105 and 101 and 100. So this is a digit preference, and in here you in a snapshot, you can see that there is a digit preference, and you need to decide what to do with this. Do you categorize it? Do you change it to different variable? Yeah. It could, but I try to have a very small bins. Specifically in here, where you have like 250 and then 275, and you have few in between. Yeah. And I think that the bins are calculated based on the distribution of the, I don't remember, I think this is what I did. But it's a good question. In here you see a rate of an event, which is 72%. In here you see another variable that is not normally distributed. I would do, if this would be an outcome, I might run a prosonic regression, or I would just dichotomize it to different categories. In here again, this is, for example, in here, this is something between 0 to 12, 1 to 12 actually. Maybe this is month, so maybe you can see seasonality in here. Maybe not. And another categorical variable, and our continuous, well, this is perfectly normally distributed. Nice to have. Gender, you would think that gender would be only male and female, right? This is what you expect from your database. But when you have a big database, you have everything. And for example, in here, I suddenly found like a U, meaning undefined gender, right? So in a snapshot, I could tell, wait, I cannot say women is 1, men are 0. I have to deal with this U. So this is something, and then I need to go back to the database and decide what to do. Variable 1, very 11, very rare event. Variable 12, well, it's kind of distributed between 0 and 29, but most of the events are at 0, like most of the values are at 0. And this is very weird distribution that you want to know ahead of time before you entered something like this to the model, that something is very weird is happening here. Also, it's 96% missing. So it's only available for 3% of the population. So I would think to consider this variable. And the last one, you can see that in here, there are actually 2 distributions, not only 1. So if you would think, like if you would have a median and a mean, you would think, okay, this is normally distributed data, but you can see that there is another bump there at the left. So maybe I would choose to just treat it as 2 different distributions. So this is Seenopsis. And let's go back to the presentation. Okay, so basically, I wanted Seenopsis to use a Panda data frame, and then I realized that in Bachon, we barely use the Panda data frame. We mainly use, we extract our data in the SQL, and then we analyze in R most of the time, and only different kind of analysis we do in Python. So I wanted Seenopsis to be first useful for me to ease my work and to my friends, and second, I wanted it to be very generic so everybody could use it. So this is why I added the CSV feature, but it wasn't that easy because once you once you have your SQL data and you transform it to a CSV, it's encoded in a different way than it does when you transfer from R to CSV. So I did a kind of a trick. I'll show you later in the code what I did to make sure that Seenopsis can read all the types of CSV. And once you have your files, you use Seenopsis. It generates graphs, and it stored it in a very specific directory that it creates because the output is an HTML file. So I needed to generate these graphs, and it all does it automatically. So it's a nice program to have, and we use it a lot of the Machon because every flat file that we have, the first thing to do is run Seenopsis, and it's so helpful, and it just cuts a lot of mistakes that we can do later on. So eventually, I would like Seenopsis to have a web application where the person who uses it doesn't need to know nothing about Python, or they just put their database and then they get the results. I might do it one time. It's very important to communicate the results of the Seenopsis to your collaborator. Like I'm working a lot with external clinicians, so what I do for now, I just take the HTML and I print it to PDF. And then I send it to them, and then we discuss. I wanted to do the Seenopsis to generate PDF automatically. It was so hard to generate PDF from HTML. It needed so many dependencies that it was too much for me. So I said, okay, I'll have somebody to write a better program to generate PDF, and then I'll use it. But for now, I'm still waiting. I'll be happy to hear if you have any suggestions. And tackling large database, for now I use Seenopsis in up to 1 million people observation with 2,000 variables, but it's all in computing power. So what I was thinking, maybe if we have a larger database, maybe I can just sample, because if you have distribution of 1 million, it would be the same distribution 100,000. So maybe I should just sample and then run Seenopsis when we have a big database. But this is something for the future, of course. And I wanted to show you everything is on the GitHub. And with all the explanation, this is the code. Wait. So if you go on my GitHub, you can see all the explanation, how to use it, the dependencies, everything in here. And for the code, because I know that you guys like to see some code. Sorry, wait. Okay, so first I use the process CSV or process pandas, the data frame, because you can automatically do it from pandas. And then this is the trick I did. I just tried it. Try to use UTF-8. I don't know why there was a difference between UTF-8, the small UTF-8 and the large. It's not supposed to be, but I kind of, because it's tested so many times, but there was a difference. I don't know why. 3 point something. The latest one. So anyway, and if you have a different encoding, you can just add it to the list and it will do it. It will make the encoding. So and many of my friends were saying, Meytal, this is not working for me. And I said, oh, what was the message? Did you get? Use a CSV file. Oh, what did you use? An Excel file. No, use a CSV file. So I added this line that's saying use a CSV and not an Excel, and specifically if they don't know the encoding, just use a UTF-8 and do whatever you need to do to have it working. And then this is open in the directory, and then this is all. I did a class, like all the logic are in here. And then eventually, what was cool about this project is that I also had, wait, I'm going too fast. So I also had a back end and a front end, and I was able to have the HTML. So this is where the backends go to my code. I use the Bootstrap, and I just realized that my brother knows the back end, the front end, so I was able to use him when I was testing Seenopsis in front of people. So it was cool. And that's it, generally. This is Seenopsis.